Hello, Dr. Huang. This is Caroline. I'll be talking to you today about a paper that I read, which is called Frontiers of Reverse Engineering, a Conceptual Model. So a brief introduction to the research paper is that the authors proposed a conceptual model using UML diagrams to describe the involvement of the following activities that are related to reverse engineering. So they discuss key processes that are related to reverse engineering, associated tools, artifacts, and stakeholders that are involved as well. The purpose of this model was to provide a way to systematize the state-of-the-art and to establish a framework to exchange research work. They believe that this model can offer a general understanding of good key reverse engineering terms and concepts. So a little bit of background on reverse engineering, especially as it applies to the paper. The authors used a definition by Elliot Tchaikovsky and James Cross, and they define reverse engineering as the process of analyzing a subject system to identify the system's components and their interrelationships and create representations of the system in another form or at a higher level of abstraction. So they use this definition in conjunction with a couple of different diagrams and a model that I'll be showing you in the next couple of slides to basically create a cleaner, uniform-looking model diagram of reverse engineering and tools and tasks that are involved with reverse engineering. So the term reverse engineering actually derived from a well-established practice of hardware analysis where they used a way to recover the design of the hardware in order to replicate or modify it. This was actually done in World War II in a couple of different ways too by one of the German scientists. And so anyway, but software reverse engineering is actually similar to this same concept of going backwards and analyzing the software system to retrieve the source code from it and understand it in that way. So reverse engineering activities are done to perform a very specific goal. And two of the goals that they mentioned in the paper is a change goal and an understanding goal. A change goal is used to create a renewed product. And an understanding goal is used to increase the current understanding of the software product. So we'll want to keep that in mind because these are the two goals that they actually kind of centered their diagram around. So here is a picture of one of the first diagrams that's presented in the paper, and this diagram offers the architecture of the tools that are used, or some of the tools that they use for reverse engineering, and this model was actually created by Elliot Tchaikovsky and James Cross. So the authors of this paper used this diagram as a base, or as the core for the model that they implemented in the paper, or excuse me, that they conceptualized. So as I mentioned before, the model that the authors of the paper created is modeled around the Tchaikovsky and Cross model, as you saw in the previous slide, and it contains key concepts of reverse engineering that they discuss. So they talk about an abstractor, an information base, and software analyzers. The abstractor that they mention here is actually, it creates the view or software view by using information that's extracted from software artifacts and is then stored in the information base. The information base is a repository which is used to store information that's extracted by analyzers. So this picture here is the reverse engineering core model that the authors created. And the gray area that you can see here, outlined in gray, with the exception of this box here and this one in a way as well for software view, is what the authors have presented as their diagram. So everything outside of the gray box is what they have designated as new elements to the diagram for reverse engineering. Actually, as you can see here, you have a change goal that I was just mentioning and the understanding goal, and these are both inputs to reverse engineering goals. So it just really depends on what the focus is that you're trying to do with reverse engineering tasks, but they basically put this here to establish that different things can be done. Okay, so reverse engineering is used to build and analyze views for different kinds of software artifacts. And the diagrams that they created here offer classification of some possible artifacts as an example. So the next diagram that I'll be showing you is actually for reverse engineering artifacts. So some of the artifacts that they used here, the authors mentioned that it's non-exhaustive, so these are just examples of artifacts that can be used for analysis. So one of those is the static analysis, and it can be used to analyze user documentation, requirements, analysis and design models, and so forth. Another artifact is dynamic analysis, which is used with execution traces, and execution traces are obtained by running executables with real-world test cases. You also have decompilation and historical analysis. In historical analysis in particular, they review sequences of file revisions that describe the artifact of the evolution history. So this is the model for software artifacts. And as you can see here, the gray here doesn't represent anything in the Tchaikovsky and Cross models. That was only in the previous slide, but I think they just did that just to distinguish the colors a little bit. So you have the software artifact here, and then the many different facets of it that can become input into the artifact. So here you have the static analysis box and all the different segments that I mentioned, as well as user documents, requirements, analysis model, and so forth. And here you have dynamic analysis and the execution trace, decompilation, and the historical analysis. And all of these eventually form some sort of input into the software artifact. Software analyzers extract information from an artifact in order to populate the information base. And one of the common kinds of analyzers that they mention in the paper is the static analyzer. And the static analyzer extracts information from an artifact by processing the file that actually contains the artifact itself. And an example of this is the code analyzer, which extracts source code information. So this this diagram here is for the software analyzer. And as you can see here, it has the different types of analyzers that can be used as a major sort of input into this and provide a clearer picture of what's happening in these different aspects. Reverse engineering software views. So a software view is a representation of the artifacts and the relationships of those artifacts. Some of the examples that were mentioned in the paper are architectural view, which is the view of the software's complete architecture. You have a code view, which lets you see the clones, slicers, and data flow analyzers. And you have a metric view, which represents different metrics of the software, metrics such as lines of code, attributes, and so forth. You also have the historical view, which lets you see the changes that are taking place in the software system. So here's a picture of the diagram for the software view. And if you haven't noticed already, all of these different aspects, all these different diagrams are smaller but more detailed chunks of each part of the reverse engineering activities and how they each contribute to different types of information. And they're actually incredibly detailed, so if you actually were to put all of these diagrams together, they would form a much larger picture of all the details that are actually needed and analyzed relationships and such. So with the software view, you have the historical view that's coming into play, the architectural code view, the metric views, as I mentioned in the last slide. So conclusively, reverse engineering includes multiple numbers of tasks that are used to better understand and enhance software. The authors created this conceptual model using these various diagrams that I just presented, and they're used to describe key concepts and terms in reverse engineering. And the model is not exhaustive in any way, and it's very much extensible and compact, and it allows for the addition of new concepts and relationships as they see fit. So the authors really believe that it can provide a way to systematize the process of reverse engineering, and they would like to continue doing future work in this regard to provide a lot more information and actually implement the diagram to test its usefulness. Thank you very much.